So today's panel is about using AI in real-world products. A lot of us have deployed things in some prototypes, have done some testing with it, have maybe done some low-scale real-world things. But there's one of the things that we've really learned is that there's a huge difference from scalability, from usability, from everything else on how AI ends up working when we put it out into the real world. And so we've got some folks up here that have all done some very real world things at varying scales. And we've got a lot of microphones up here, so apologize if we get any hisses or whatever. We'll try and keep them pointed away from each other. So we've got a lot of folks up here that have done some stuff at some real scale and done some very interesting things. And so we want to talk to them today about what's different when we start putting it into the real world. What are you going to have to think about and worry about as you're doing this in your lives? So the first thing I want to talk about is how is AI different than other modes of communications and other things that you've been doing, especially when we start talking about telephony and start talking about things. So when we're deploying AI versus deploying a human agent, or when we're talking about using AI in telephony versus using a textual interface or a graphic interface, what ends up being very different about this that we have to start thinking about? So Lily, let's start with you.
I mean, there's so many things to think about when you're building what is essentially a stochastic system. I think at the same time, right, like there's two sides of this coin. Like I don't directly interface with a lot of folks who are like on the operations side of contact centers, like managing agents and stuff, but I have often heard that the best human agents are not the ones that follow the script. Right? And at the same time, the best LLM applications in many ways are the ones that follow the script. So there's this kind of like strange divide in how people think about what a successful LLM-driven application is. I would also say, right, like in the same way, I don't know, text, by the way, like, and there's been a lot of folks who have talked about this, is very, like we're talking about chat support, like very turn-based. Right, you can walk away for 5 minutes. Essentially, when you're done talking to the chat support agent, by definition, you're pushing enter, like you're issuing your message, and you can walk away for 5 minutes. That's not really true in voice, and so the amount of things that can go wrong, right, just from someone saying like, you know, if you have a very simple orchestration framework, the way that orchestration framework would work is after the user says something, you generate an LLM response, which gets sent to text-to-speech, and if a user says, hang on, give me 5 minutes, maybe the right thing to say is, nothing. You're like, okay, I'll be here. And so, I don't know, the surface area is quite large. I would say many of the folks that we work with who are powering, you know, millions of calls a month are still, for what it's worth, QAing their application in a way that involves calling themselves, right? Like the VP of engineering at a company that's supporting phone ordering for Domino's is calling themselves. And not only they call themselves, they're calling themselves in different regions. So a lot of this, and I think probably Justin could speak to this too, it's just like a lot of strange manual QA of a system that, by the way, is agentic. Very strange. There's more I could say, but I'm sure other folks on the panel.
Yeah, so Justin, the usability, the latency, the way people use the system, what's so different about AI on a voice call than anything else?
Well, I'd say you're going to be replacing one of two things. You're going to be replacing a human, or you're going to be replacing an IVR. And if you're replacing a human, you don't have any human feedback anymore, right? If something goes wrong, how do you make sure that is giving you feedback saying, hey, what you've written is a bad prompt? You don't get that built in. So you have to think about that, and how are you going to get feedback from that? And when you make a change to something, how is it going to have impact on the caller experience? So if you're replacing an IVR, you're already kind of used to that. You have to make sure your IVR handles things correctly. You can write a bad call tree, right, on an IVR. Very similar on an AI agent. You can write a very bad one.
Brian, you looked like you had something to say there.
Talking about the testing, there's one thing Abby and I were discussing this earlier, and it's something she needs to add to her talk. But I've noticed, like myself and developers and engineers that are developing these products and services, they test in a very different way than actual humans do. So you have to be very careful as an engineer how you engage, because you get false sense that it works, when in reality, when an actual human interacts that's not barking orders at it, or giving it all the data in the right format every time. So it goes back to testing and ensuring that you have some kind of feedback loop, which, like when we deployed our SIA to answer the phone at SignalWire, we take the summarization and the call recording and we put it in a Slack channel and we pick it apart. So we have real life interactions that have allowed us to see some of these edge cases where humans don't behave like an engineer would when developing them.
So, Lucas, that reinforced learning that's happening there, you're building a lot of models. Where does this come into play, and how is that different in a voice channel with AI than maybe an AI channel that's not voice?
I will echo that the most important thing in any AI-driven service model, every step of the process is evaluations. I mean, and not even tests in the standard form of like unit tests, or like does my function operate correctly with my larger system? Is my model delivering the results that I want it to? And the hardest thing going from POC to production is making sure that your tests and evaluations of that model are a very good aggregate for like what that human is actually going to want. We personally use reward models, so we will give in working with a customer, and again, this isn't. I'm mentioning this only to give you an idea of what's possible, but asking for 50 golden samples from someone and saying like, what is your ideal interaction, whether it's a chatbot, a voice assistant, what is your ideal flow over a conversation, 20 turns? And then you have to generate a lot of synthetic data that matches that, both from a task specific and a semantically similar sense, so that you're getting the same behavior. And then you train a very tiny, it's not even so much a reward model as much as a classifier, such that it spits out, whenever your model answers a question, how close that response is to what the customer or the client desires. And then we do use a form of reinforcement learning to enforce that. Taking that out of, it's unrealistic to expect that every developer, especially if you're working with like an OpenAI API or a Claude API, you're not going to have the ability to do preference optimization over those. But you can use that as a proxy for how do I optimize my prompts, which we were speaking about earlier. How do I optimize my system? How can I basically do my own form of manual human feedback learning? So evaluations is the first thing you should build. What do I want this thing to feel like? And then as you continue building it out, modifying those evaluations to be sure that they're close to what your end user is going to expect. And then once you put it in production, if your results in your evaluations are telling you something different from what your end user is experiencing, it's not the end user's fault, it's your evaluation's fault. And you need to adjust as such.
And so those golden samples that you're bringing in and building the evals around them, are you building those in voice? Are they audio samples? Are they text samples?
Depends
what kind
the
of
medium.
examples do you want to there?
It depends the medium. It almost always ends up resulting in text. If you're just taking a transcription of the conversation, but that is 50 is a number that I've found to be, and again, this is unique to working with customers, but 50 is a number I feel is realistic for a team of people to sit down and either, generate with another model and then tweak it and make sure that it's exactly what they want, or write them down themselves. That's a reasonable ask of someone, whereas if you say, hey, go get me 50,000 great samples, they're not, Quality with data and these systems is by far more important than quantity.
And so that the samples that you're doing and the evals that you're doing, you're testing the quality of the content of the response. What about the latency on the call? Tony, you've been building a lot of things recently with bringing that audio in. How are you doing that testing to make sure that the latency in the samples that you're bringing in match what humans are actually doing?
One of the ways we did that was to have it answer all of our calls inbound. We have a phone number. From the minute we had even a prototype, we were already testing it that way. What you'll find is people don't know there is such a thing as voice AI yet. The majority of people, even though they're in the tech community and using our products to build communication stuff, when it was new, they're just, I want to know why my bug isn't fixed or whatever reason they're calling, and then they're like, why is this robot here? And well, whenever I hear a voice that isn't 100% human, the first thing I do is say, support, human, and like, I played around with different things. I prompted it that if the user says human, to respond, there are no humans left, we eliminated them, you're next, or something like that, just as a joke, haha, just kidding, and went through a bunch of different stuff, but then eventually we got it to the greeting saying, I don't understand single words, you need to give me natural language so I can understand you. And then people started actually like saying what they wanted to it, and from there, what you could find is that like, in order to get the latency down, you have to be very careful about how you process things. And there's different techniques. So if you came, just like there's different techniques to do lots of different things in engineering, you have people splitting up and working on like different disciplines, right? There's a whole group who wants to make speech-to-speech models, right? So you're taking 100 things and just deciding you're not going to care about those things anymore because I want to achieve my speech-to-speech model, so I lose a bunch of stuff that I could have done early. If I do a text-only model, I have more power, but I want to give away that power because I want to gain latency because I want my AI model to understand and generate speech and leave out those other things. And so we've explored how to work with both of them. We started making, for instance, tool calls. We made up that before it was a thing. We didn't have that yet, so we just came up with our own, like taught the LLM to say certain magical keywords that would like gateway to calling a webhook. We had that like in the first week. And then it was hard because it was like screw it up all the time. You're basically trying to teach it that in real time. So like getting those things processed and handling them in time, it really contributes. And then as the discipline of making text-based LLMs gets more work, then it rolls down to us and like, oh, there's like, now they know this concept. I don't have to teach it to them in my prompt anymore. And then all of a sudden we standardize around tools and stuff. So we get into this world where the AI is, we're hoping that it's going to do all the work for us in the fastest possible. But the problem is that there's going to be this like codependency between real programming and the imaginary stream of consciousness that AI gives us, right? So handling that as fast as possible and like steering it towards something coherent, dealing with latency is really important to us because we have already solved latency in regular voice over IP, which was hard enough. There can go do a whole talk about how hard it is to make like a regular SIP to WebRTC call not have giant lag in it. But you're adding that together with like the minute amount of time. If you listen to Abby's talk earlier, before people start wondering, oh no, it's broken. So having a limit and speeding that up and testing it and making sure that you have to spend it like money. Okay, I really want to use this voice provider, but I know it's going to add 200 extra milliseconds, but this one sounds shittier and it's faster. And this one, if I use this tool every time, I better make sure that the website on the other side isn't down, otherwise it's going to hang and cause all kinds of commotion. So you have to like bake up, you almost spend it like cost when you're creating your different bot.
So then as we're building these, and we've touched a little bit on the testing and the users and you're prototyping things and you're prototyping that lag and you're prototyping the talking to a RAG or talking to a MCP server or something like that, you're trying to optimize for this real-time voice, and you're pulling in this outside context. Are there some? You're not going to necessarily notice that when you're building in a prototype, but then your users will. So, are there some techniques that you can use to optimize that for production and to know where you need to optimize that for production?
I think what you need is a blind test subject.
Yeah.
the anomalies that should be discarded in trying to test the performance of having a conversation with the voice bot are all the people that are just trying to break it on purpose, who will like ask it silly things and whatever, and like, see, it's stupid, you know, like all the people that post, they talk to LLMs and make it insist that 2 + 2 is 5, you know, because it finally gives up after the 30th time you insist it's true. Like, fine, dude, it's 5. Leave me alone now. So like, there's always someone trying to do that. So that their use case is not as important because they're just like looking for something absurd to do to it. And then there's like people who are trying to have it be unnatural as a standard. Like, it's too slow. It's like these blind people who don't know that they're talking to AI until the call answers and they have a conversation with it. We've observed the latency of that person is double what the AI's was. So like, one smart aleck is like, your AI is really slow, and the real people talking to it, it's like the people are really slow. Like the AI is answering in under 1 second, 700 milliseconds, 500 milliseconds. The person takes 2 seconds to answer the AI back.
But it's not just the people that are trying to break it and finding things that are like that. I mean, when Siri pronounces my mother's name wrong, and that's amusing to me. And I'm not trying to break Siri. I didn't misspell it on purpose in my phone or anything like that. But I find that amusing, and I'm not going to go complain about that. But you know, if you're talking to McDonald's AI and it can't pronounce McRib, that's something that people are going to point out, and it wasn't them trying to break it, it's just them trying to use it naturally. And while I don't care that Siri pronounces thank you, Siri. While I don't care that it pronounces my mother's name wrong, I bet McDonald's brand manager really cares that they're pronouncing McRib wrong. So Lily, how is that dealt with, and that's solved with not just people trying to break it, but the latency and the round trips trying to go back to the menu, and how do we fix that, and how do we do that differently in production than in a proof of concept?
I guess there's a couple things I want to say. One of which is I called the Chase Bank toll-free number, their IVR system, and just I was really curious to know, like, this IVR system. And by the way, it has some basic, you know, it has DTMF, but you could also say things. And the time between "thanks for calling Chase" for Spanish, press 2, and then the first thing that the bot said was 65 seconds when I called. And so, point being, right, like, I think there's a lot of applications where the status quo, for worse, not for better, is that, like, the application was built 15 years ago in an outsourced manner, and they are just now beginning to realize that it could be better. And at the same time, right, like, for many of these applications, they're seen as a cost center, and therefore, right, like, and by the way, I've been at, like, you know, enterprise contact center conferences where, depending on who you're talking to, like, sometimes people describe their callers as hostages. I also can imagine a future, right, where that, in the near term, is very different, and that future is happening before our eyes. Okay, flip side of that, right, at the drive-thru, not only does the user care about how fast the bot is to respond, but McDonald's cares really a lot because they're trying to get cars through, right? And so if the bot takes 30 seconds to respond, that's 30 seconds when they're not taking an order. And so I think, all else being equal, faster is always better. I also think we just know from a customer experience perspective that there's some things that are too fast, and there's kind of a sweet spot there. How are people QAing, like, every part of the model stack, from speech recognition to LLM response to TTS? I think, to be perfectly frank, they're figuring it out in real time. You know, when we started working with, like, a lot of these fast food applications, again, like, the VP of engineering was calling and being like, "Hey, Rhyme, you just mispronounced avocado," right? It's stuff like that that's really basic, and at the same time, I mean, it's true, like, Chipotle is hard to pronounce, and by the way, a large swath of the population pronounces it as Chipotle, and that stuff's hard to account for. And I don't know. Long story short, I think like every single part of the stack is really important. Speed is really important. How are people queuing that? I think the best way is still like looking at the waveform of a recorded call and just seeing when the last thing the human said ended, and then when the beginning of the bot responds. Because again, a lot of model providers, by the way, like time to first token might be good, but throughput is horrible, and so it's really hard to tell just from like an individual metric how performant your application is.
And so, with this latency and the performance, one of the things, Lucas, that you showed off was the small language models responding so much faster. Is that a significant enough portion and a significant enough improvement in the overall latency of the call that that's the only solution that we need, or are there other optimizations that we need to do in the chain too?
I wish it was the only solution. It'd be awesome.
Make a lot of money.
I'd make a lot of money. No, it's an improvement. I mean, it's powerful, and that's not just SLMs in the context of like, oh, it's on device, or oh, it's on prem and it's secure. The speed that you can get using an SLM is very. I think for our endpoint for our 4B model, it's time to first token is. I don't want to quote a number that's incorrect, but it's up there with kind of the highest you'll possibly get, and then our throughput's around 280, 300 tokens per second. So you can cut out a lot of the, especially once you add in reasoning models. Like if you can't use a reasoner model like in your voice agent, that it'd be funny if it was like transcribing its chain of thought, but it would take a very long time. So SLMs are an awesome tool there. Again, when you're getting into extremely long 30-turn conversations with multiple tool calls, they can start to fall off in efficiency. So I think the overall, there's no one-size-fits-all answer for how to build a LLM or AI or Gen AI or voice application. The ultimate thing is getting a very good sense of what the right tool for the job is, and then being able to mix and match those to deliver. So SLMs are a very powerful tool. I would use them in many of your chat assistant, your customer support, your retrieval pipelines. But if you're doing some form of automated code review or tutoring on very complex topics, or even just a situation where you're having the model work back and forth with someone because they're just talking about how their day was and they're wanting to turn that into an action plan for tomorrow, you do need to use larger models, and that lowers your latency. But again, right tool for the job.
That would be illegal in Illinois, where we're sitting as of yesterday. There's now a law that you cannot have you cannot have an AI provide you any advice about your well-being or anything in Illinois. Which, yeah, I'm just picturing though your reasoning model vocalizing its entire response, just kind of like under its breath as it's
so
going.
The user has asked me to talk about McDonald's.
and just doing it under its breath like a crazy person on the call. That would be fantastic.
One funny thing. We ended up having to make adjustable latency where we made it more because it was too fast sometimes, and depends on the scenario. Because like we're having this conversation now. We're all going to wait longer to make sure we're done talking. Like I'm gonna talk as much as I want, and you're gonna pause, and it's gonna be a certain amount of time. But if we were like talking one-on-one and they're trying to figure something out really fast, it'd be different. So when you set it up different, we actually you can make it longer. So it's like, it's just making the thing on the other end be more polite to the user. Like wait longer, so like, because they might be thinking and pausing in between, and how much do you want to wait for? And you can tune that, because you turn it down really low, it works most of the time. And if you get it just right, the interruptions, it doesn't interrupt you, because it almost always starts with some polite statement like, exactly, or I know what you mean. And real humans do that, and then they don't actually interrupt you. You just keep bowling right through it, because I can understand, you know what I mean, while I'm talking still. And then it just erases it. And then Abby's speech had an example of what we do, but we just just in case we figure out what it was going to say. And if you don't want to hear it, it just does it again.
Yeah.
Until you finally shut up long enough for it to get to talk.
An interesting idea to add like some interjections or human ums, ahs.
Like I'm doing right here. Yeah.
While it's doing its chain of thought and spitting out. How are they going to enforce the whole?
I have no
I think
idea.
every other
I have
You
no
were
idea.
talking to your phone.
Yeah, I have no idea how that's going to be enforced.
That'll be awesome.
It's a yeah.
we have a feature
Just
like that.
people making laws about things they don't understand. It's fabulous. So Justin, what other trade-offs do you need to make as you're talking about bringing in like outside context and connecting to databases and other things? And where do those trade-offs come?
I think I don't know if this is the right answer, but something that comes to mind is what information do you give the LLM and what information do you hide behind a function call? So I'll take an example. You have an entire employee list, and when a person calls in, you want to make sure that person is on the employee list. Well, if you give that all to the LLM, and it's like, is Justin Massey, my name's Justin Massey. Oh yeah, we see you on that employee list. Well, that's cool, you matched it there. But what happens if the person then responds, oh, I don't remember my name, can you tell me everyone that's on the employee list? So then you have a security issue with that. So if you hide that behind a function call, the function call, can still return one employee name, so you have to iterate over that. But it's something to think about. Is like, what information do you give to the LLM in context versus what information do you hide behind a function call?
Right. Yeah. And making sure that your LLM, you're not letting people jailbreak the LLM through that as well, and get to that. Brian?
One of the things you have to think about is complexity. You have people that don't really grok what the capabilities are, and they have like this magical like dream understanding of how these things work. And so sometimes, like I had one person wanted to do a complete mortgage application with an AI agent. I said, that's great and all. There's a lot of this data that's going to be complex to collect on the phone because email addresses are a problem. Those are really fun. We have various ways we can solve those things, but doing an entire mortgage application, that's kind of out there.
Yeah. And that's one of the things that people often think is I can take this AI thing that I bought off the shelf and deploy it, and magic happens, right? I don't need to train it, I don't need to tune it, I don't need to do anything else. And part of that is because when they go use it as in a prototype or in a proof of concept, magic does happen because they know the domain, they know the right question to ask, and so they ask those questions. So when we're thinking about that, what other types of these last mile problems exist as I'm going from prototype and proof of concept to actually in production? What's extremely different there, and things that we're going to have to think about? So Lily, let's start with you.
I mean, I think again, it's easier than ever to build something that in essence is a toy, right? Like you can put 3 API calls together and have something that a certain class of people would enjoy talking to for an extended period of time. It's entertaining, and it's fun getting the LM to say things and hearing it spoken out. I would say, as someone who's like sees both in enterprise and then startups, a lot of different people building a lot of different kinds of application, I can tell you, like at the startup level, the churn for some of these more horizontal focus like voice applications is probably like 3-month churn at some of these places, probably like 75%. And I think that's truly because people don't realize that some of the things they want to build are impossible still. And not impossible, right? Like I think not optimal. That's a great way of putting it. And to your point, right, Brian, like a lot of that is, there's so many crazy edge cases that, like, by the way, humans really struggle with too. Like if I had to tell my email address, and I often do, and it's shocking how hard it is to be like, oh yeah, it's Lily, and that's, by the way, with 1 L, and at Rhyme, and by the way, here's how that's spelled. And I usually have to say that 4 different times. And you can imagine, right, like dealing with 3 different models that are trying to do that, it's very hard. And so, I don't know. There's just like in any other engineering project too, the amount of scope creep that can be involved. We're like, oh, we got to do this now. I want to do 10 other things, and I don't know. It's just it's not stepwise like you might think it is. Like everything you want to build adds maybe potentially like exponential complexity to the project.
Lily with one L is just Lee.
Right. Yeah, it's actually two L's, but they're not together. Yeah, you start saying insane things. Which, by the way, the L with it, I can guarantee you, I have no idea how to interpret that. It's two L's, but the L's aren't together.
So Brian, what other sorts of last mile things, as you're talking to customers, have you run into that's just different from going from prototype to production?
The thing about the complexity that, people, you got to water some things down. And one of the things I tell everybody when we're approaching like our AI agent to start building, if I'm telling you to sit down and plan it out ahead of time, you better do it, because I'm not one of those people that'll tell you that. But in this particular case, you better sit down, put pen to paper, figure out your flow, how you're going to interface with things, draft what function calls you're going to need, what you're going to interface with, and how you're going to interface with it before you even start prompting. Because if you don't do these steps, you're just shooting from the hip and you're going to have bad results.
Justin?
I think we're all developers, so we're all thinking in the developer sense right now. And I realized very quickly when we shipped our first version that I needed to stop thinking like developer. I mean, Brian's telling me that all the time when I'm writing system prompts. He's like, you can't do if, then this in a prompt. Stop doing that. But more from an operational side, I listed out every single feature I needed to build to be feature complete on this product. So I listed it out, had my customers agree to it and said, yes, this is great. Once you have this, you're done. We'll pay you for it. But then I forgot to take into account that humans, the way you feel on a phone call cannot be written in a feature list. I felt good about the way that phone call ended, and it's hard to talk on that, oh, that was latency. So it ends up being these cultural issues. And so if you can get ahead of that much earlier on and get adoption and buy-in from, if you're selling it into the executives, or if you're selling it internally or externally, getting adoption and having those conversations earlier on, rather than to spring that on at the very end of the, hey, we did all this stuff, and them not even understand any of that. I think that's really important, is to think about how someone's going to feel on that phone call and bring that forward in the conversation earlier, rather than focusing all on the call flow. And I do agree with Brian. You do have to draw out your flow chart.
Yeah. Lucas, have you seen any promising prototypes that just completely fail and break down in production?
No, well, yes, that happens. But what comes to mind is, especially with these complex, agentic systems, is there's a difference between getting it to work and getting it to be good. These conversations reminded me of, we were working with a pretty big telco, and they had a very bloated agent harness. The number of the prompts were very unoptimized. It was clearly them trying to solve for things that they likely should have been doing in code, but they were trying to solve it with a prompt. And they wanted a custom model that they could run in their environment that was super fast and was optimized to be absolutely delightful in these conversations. It took a tremendous amount of effort to get it so that a model of this size could handle the amount of context bloat and go through all of the steps, because it was like a meal planner or a weekend planner or a travel planner, and there were many. It not only had to generate the function calls to go out and get the information about what events were happening that weekend, it also had to offer 4 options to the user so that they could just click it, and it was very complex. And we finally got it to almost be perfect integration-wise. Like, it was so good. It went through every step. It passed the evaluations, and so they put it into production with like 500 people. And I remember looking through some of the logs. It was for a meal plan, and the user, one of the options the LLM generated was like, do you want to cook this in the oven or in the microwave, or where do you want to do this? And the user said microwave. And then a little bit later down in the conversation, the model suggested like a series of meals to cook, and one of them was chicken risotto. So the person clicked chicken risotto, and I hadn't even considered that the model should maybe reassess the microwave if they're cooking a chicken risotto, because that's not the right, you can't do that. But then it gave them this very detailed plan on how to make it without considering that, like, no, I mean, you have to like stir the thing, you have to take it out of it. It was saying, oh, it's going to take 30 minutes. No, it's a microwave. So it worked. It passed all of our evaluations. It went through the flow better than any model that existed. But when you get into like real things with real issues that real humans are having, the amount of synthetic data we had to generate to get it to do well in the system wasn't an aggregate for how well it would do with real people. So again, there's a difference between it working well and it being good. And I think that you need to do quite a bit of work after it works, pun not intended, to ensure that it's actually delivering the response you need. So no nugget of wisdom other than after it's integrated well, make sure that it performs well too.
Maybe one other thing is just test early.
Yeah.
Testing early would, I mean, like for me, I forget about that sometimes. Like put real calls on it as early as possible.
Yeah, and then also go in and add a like if microwave, no chicken risotto, you know?
Unless you want crunchy chicken oatmeal, I think is what you'd end up with microwave chicken risotto.
That actually sounds kind of good.
Okay, I'm never going out to dinner with Lucas. So Tony, are there things that you've seen in prototypes and proofs of concepts and things with customers or even internally that once they didn't survive contact with the real world, and what happened?
I think the progression is there's two, like I was talking about before with different disciplines that are all split off. So the world who wants to use Claude Code to build fun things and give it 30 tools and have even like you have to babysit it and you're there to tell it it's being stupid, but you give it all the tools, right? I played around. I made a shell MCP where it can actually go open up like a VI editor and run commands in it instead of just its usual command line stuff. And like that's one thing. Like, there's a hope that someday that some kind of LLM, given all the tools, will just drive around by itself and do everything fine. That one was hard. That's the same as trying to make a Tesla drive all the way to California. That's going to be a bit. The voice one is very special because when you're on a phone with AI, it's mostly just to deal with something that requires immediate conversation. Like you're not like waiting and taking 30 turns and the user can't intervene because it's a customer. So like they're talking to, you can't correct the AI and stuff like you can. So when you build something like that, I think as we evolved, very quickly learn to make the model as basic as possible on purpose and to take away as much as you can. You don't tell it the truth about what it's doing as much as you can. Because the more you rely on it, the more you're going to have these like probability problems because everything that ever happens is something that is plausible. So it will just, when I first made something and just testing, right? Like I got the voice system up and made just a generic, I want to order a pizza. And it works fine. I can order the pizza, submits the JSON when I order it. And then just playing around with it, I don't know if I was showing it to someone or just doing a routine test. Well, all of a sudden it was out of pepperoni, just because it felt like it once, right? Like we don't have pepperoni today. It's not in the prompt anywhere. It's just something that might be said. Out of a million times, if someone orders a pizza, there might be no pepperoni one of those times. So it just happened to pop up. So like. Sometimes, like, you got to look at the pieces. Like, how many decisions are you allowing this model to make? And how can you jail it, basically, so that there's a codependency between the engine that drives it and the LLM's role in it. And me being influenced by being a web programmer before there even was any of this stuff, before there was even voice over IP or the ability to do anything, we made web pages. And web pages were a similar way because you couldn't put the fun stuff in the browser. You always used to joke that's why the internet can't have nice things because you put it all in your web app. It's in the browser, and the people hack the JavaScript and start calling all your functions and doing whatever they want with it. Well, you have that same kind of danger zone with the voice stuff, because you don't put all of the fun stuff down into the agent and let it deal with it all, because it's going to portray you with it. So you have to trick it into doing what you want. And the basic things are to move the conversation along. So that the tools are okay for looking things up and that, but you want the tools are also helpful to move along the conversation. Well, you just give it a single goal, like figure out the people's name and then call this tool. They don't know that once they call the tool, you're going to hit it over the head and make it into a whole different agent that has different ideas about what to do next. It doesn't have to know. If it did, it might do something wrong. So you give the bare minimum, and you have to orchestrate it really well, so that, because you don't have the luxury of the user correcting it when it does something wrong.
So that probability problem that you mentioned there is, I mean, something. It's in some ways the same thing as the microwave, the chicken risotto. That when you're testing something in a prototype, you have a finite number of tries, but when you put it into production, you have an almost infinite number of tries, and so there's an infinite number of ways that it can go wrong. So when you're thinking about, I'm testing that prototype, Lily, have you seen any ways to increase the chances that those things go right and that you avoid those probability issues?
Again, like I have a very bird's eye view of building voice applications, just because we're so narrowly focused on the speech synthesis side of things. But what that does mean is that I've seen a lot of things, and I hear customer complaints. And I also have a vision in our roadmap of like owning more of the modeling stack. And so I have some dilettantish, I have to admit, like opinions about LLMs just from having trained speech models. And I would say, right, like, and I think this is the sort of balance that people are playing now in terms of orchestrating between SLMs and LLMs. And it's to be honest, it's something I haven't wrapped my head around, but it should go without saying, although I think this is strangely a contrarian opinion, but the more parameters that you have devoted to a single task, the better a model will be. Right. Whereas I think the hype cycle that we're in is like, if you have enough parameters, it can do everything. And that's kind of funny way of thinking about it, because it should stand to reason that if you have half the number of parameters, but it's doing 1/3 the amount of things, that would be a better model. Right. And I think like in a lot of ways, what I see is that the more things change, the more they stay the same. And that is to say, right, like the reason why you have to have a call flow is because we've kind of, by the way, I'm not saying we've reinvented IVR, but worse. I think it's like, essentially, it's like, I don't know. I sometimes think like it depends on our customers. So we have so many customers, by the way, who are like, we're not building IVR, and then we have other customers like, we're building conversational IVR, and we have other customers who are like, no, this is an agentic whatever. And the latter gives me a pit in the bottom of my stomach, because I know that expectations are sky high. And I would say, right, like the cutting edge teams that we see and that we work with are, you know, for any given call, there might be 20 different LLMs making individual decisions about where in the call flow that customer journey is. And that strikes me as funny, right? Like the promise of LLMs is like one model to do everything, and somehow we've reinvented the wheel. I mean, for what it's worth, it's better, as far as I can tell.
Well, I mean, pitting two models against each other or using different models for their different capabilities is something that happens a lot, whether you're in voice or not, and using them for different things. It does make it harder to. It increases that probability surface of where things can come up. So when we're talking about taking that simulating essentially a real world usage on a prototype to find out, is this even good enough to put it in production? Are there ways that we can, Justin, the things that you've seen happening here? Or maybe this is the wrong question. Maybe we don't bother to simulate it and we just throw it in production and find out what happens.
What's the...
So with the, you have a prototype, you have a proof of concept, you want to bring it into production. What are you doing to make sure that you're seeing real world type of usage to eliminate some of these probability problems of things going wrong, or of large groups of people using it in ways you didn't expect or plan for that or test for that?
I think this just comes back down to development, the way we've done development for a long time. We've done A/B testing. Route percentage of your calls to the AI, and then the rest of them go back to the humans. Just put calls on it, see what happens. Like depending on the use case, that may be okay. For our customers, I'll just tell you, like, they call in and say, hey, we want to put sales calls on this. And I'm like, no, we're not doing sales calls on this. We're going to do back office calls on this first, because you need to learn how this works before, you start putting it into production. So, and you can put 20% of your back office calls on it and put 75%. So just put it on there, start getting real data, because, we can talk about testing and testing and testing, but synthetic data is synthetic, right? We need some sort of real traffic on here. So I'd say just ease into it. It's what we've done with real life deployments since forever.
Yeah. So Brian, you just threw it straight into production and had it answering the main line.
Yes, we did.
How awful was that? How badly did it go?
What percentage involved microwave?
No, there was no microwaves involved. No risotto was harmed. No, it just basically was, I saw the potential. Tony and I drafted a prompt, and I just plugged it in, and I hooked it up to the Slack channel to take the summarization and the recording and report on it. And then we just started reviewing those one by one as they come through. And like Tony said, we learned a lot from the behavior of people. And the problem that we're battling against is these decades of really bad IVR implementations. Pay attention, because our menu just changed. Yes, Linda, 5 years ago it changed. And you have these IVRs that are inconsistent, where people have left and joined the company, and it changes voices when you press 2, and it's a different voice when you press 5. And there's no consistency, so you don't have... You're battling against that, but when you bring like the AI into it, you get that consistency, and you get that you don't no longer have to go 14 menus deep to get to sales. Just tell it what you want. Speak in natural language, and it can figure things out a lot quicker, and it's a better IVR.
I think one thing to really point out that Brian skimmed over is he looked into every call. He had visibility into it. Whatever system you're deploying, you'd better make sure you have visibility into it, and like good visibility, like whether it's latency, and like when I'm looking at SignalWire call logs, I'm looking at their debug logs, and I'm also looking at the final transcript. You need multiple levers of visibility, and then I do a final transcript on top of that. I'm looking at 3 different transcripts when I'm trying to figure out why something acted a certain way. So really important to have good visibility into what's going on inside your AI agents.
Yeah, because you could give it the wrong wording, and you have to think about what did the customer say, and then you have to put yourself in a different mindset to figure out why the LLM evaluated that a certain way. And then sometimes it's just the wrong wording somewhere in your prompt that makes it do this occasionally. Yeah. So you have to be very strong words. It's dangerous to use words like never, because it will never do something then.
Also making a list. If you start listing stuff, now it becomes more and more absolute. So then what would have maybe worked every time because you listed 3 different things, now you have to list every possible thing. And then in that you get into a trap where every time you hear one, oh, also this, or this, if that happens, or that happens too. And now you've destroyed it and it's useless. And I think one of the things that's interesting is that because we chose to look at it from a usability first standpoint, my thesis when I started this was I'm very deep into a discipline of building something already, and this is going to help it be better, not like a new opportunity, right? So I'm looking at it, how to use it, because I have demons inside telling me to go try and make something new in the same, I don't want to get involved in making models or any of that stuff, because I would, and then I would be pivoting away from my entire business strategy, right? So I use that discipline. I'm making it work. And what I'm trying to make sure, from my perspective, which is unique that way, being, say, like a usable product, is I also solve the problems with code, right? What I want is that it won't matter what your prompt says sometimes. Like, that didn't happen because your prompt sucked. It happened because it wasn't harnessed properly. And I'll write 1,000 lines of C code that that it will make sure that it works right. by doing things that you have all these abilities to manipulate the conversation that can really steer things and make the experience better. So there's sometimes we want to focus on that too. We want to make it so that the prompt that the user provides to us is not going to matter as much. Like they don't have to describe it. We've had people, we did like a hackathon and some kids came in. One had like it was the whole context window. I don't know how they even generated. They wrote a prompt that was so hard you couldn't even read it. It was just like as if it was a program. Like they think the prompt is a program, and then it just you don't even understand. There's like 4 overlords above you that are controlling the prompt, right? Like we're manipulating your prompt, and someone's manipulating ours, and someone else is manipulating that prompt. And the more you rely on that, you're getting that you don't even know like what's going to happen, because like one word really matters sometimes, but we don't want to make the outcome change. But little stuff like tweaking. An example is when I first made things, I made a test bot that's like 2 sentences long. Like your name is Franklin, you are an expert at Star Wars, right? And then like. So then I just talked to him to ask him questions about Star Wars. The model already knows everything about Star Wars because it's 40 years old. But like, used it. A new model comes out one day, and all of a sudden he won't do one of the things he always used to do. And then it boiled down to the word expert. Like just the word expert, you are an expert at Star Wars meant I am not an expert at anything else. Therefore, I'm only going to talk exactly about only certain things. Like even though I have a tool that lets me check the weather, I no longer am allowed to use it because I'm an expert at Star Wars. And you just take that one word away and then it's back to normal again. So
I'm personally looking forward to replacing all bad IVRs with bad voice AI
the worst voice AI is better than every IVR.
Let's pivot a little bit to talking about some of the technical deployment and technical integration challenges. So, if you're bringing voice AI in, which is the AI systems are newer and less battle tested and such than some of the things that you're used to using in a telco land in your mission critical voice. How are you balancing these cutting edge capabilities, and how are you seeing customers do it? With the reliability that they're expecting in these systems. So Lily, you've seen a lot of these.
I have seen very large enterprises who have an IVR for a long time work through this. And the approach that I've seen that has worked the best, although it hasn't translated into a large amount of text-to-speech volume for us right away, is by, there's a really long preamble for saying people start with the easiest stuff to automate first, and then they work on to harder things. So, right, we were working with a large software-focused BPO that was, there's a lot of customer support, but the first thing they automate is not anything. They don't automate anything. All they do is change the IVR to, again, being LLM powered to collect as much information before transferring the human agent as a sort of triage, right? So like the goal was not automation. The goal was to collect information that the agent that would then not have to collect. And by the way, LLMs are really good at this. They're really good at asking questions. They're really good at chatting. And with a really high quality voice, people are like, literally, the bot is like, now I'm going to transfer you to the person who can actually help. And the person's like, no, I want you to help me. I want you to help me, to the bot. And so, that for me is really promising because it means that they're going to be able to automate stuff in the future. But at the same time, right, like there's many use cases where you can't automate, and maybe the right approach is just to collect as much information as you can during the, again, whether you want to call it IVR or not, that portion of the call. But yeah, I think piece by piece makes a lot of sense, and I think also there's going to come a time where people are going to need to rip the Band-Aid off, so to speak, and how they go about that, I honestly have no visibility into, but it makes sense. Use case by use case makes sense.
So, Lucas, are there some places that you're seeing somebody trying to integrate some of your stuff into their mission critical, business critical phone system? And you're looking at the brittle chain of code that's running along this, thinking this is a far cry from what they're expecting from their telecom reliability, and how are you balancing that and helping set those expectations?
It depends on the scale of what that system is trying to accomplish. There's a pretty big, I would say most people agree that like you're truly the autonomous agentic systems, which I'm hesitant to say because I think that like leads into like, oh, AGI, super intelligence. Is going to be a suite of models and classifiers and routers and functions and harnesses. It's not going to be a single monolithic model. At least if you're looking at scaling up the current architectures we have. That said, I do use systems when we are dealing with things that are super critical. So you have models checking each other and classifiers and ensuring that it's not spewing out hate speech and things it shouldn't say. Oddly enough, most of these companies, they do not give as much of a concern around it like saying inappropriate things. The models are usually pretty good at doing that. They're actually more concerned about like if you're dealing, and again, this is not an actual customer, but say like you're dealing with AIG or Geico, they're more concerned about the model suggesting something from Aflac. So it's guardrails, but like business guardrails, not safety guardrails, which is very interesting. I am also I do a lot of structured output. So there's tools available. Outlines is a great one, and then many of the APIs provided as well to set a rubric and a schema that the model has to follow. And if it doesn't follow that schema and check all of these boxes, it will keep retrying and regenerating from the last time it failed until it gets out. Great for reliability. The models suffer. Their performance gets worse just when you constrain the amount of space that they're allowed to generate from. They're not going to be able to pull as much of the information within their weights. And it can also slow down generation because, say, it's failing a lot. It has to keep going. But when you're in mission critical, like we are driving revenue, that we are adding a new piece to, replacing some old school classifier from 10 years ago that was 15 million parameters with a 3 billion parameter model that can take in much more context at once, you have to prefer redundancy and reliability over anything else. As a researcher, I get like so stoked if something works 95% of the time. That's you tell that to someone where millions and millions and millions of dollars are on the line, and you're telling them, oh, so it's going to fail 5 out of 100 times? Yeah. They're like, no, that's not possible. So you just have to add so many steps to make sure that it works. And again, it's using the right tool for the job. Yeah. Tip there, though, is like most of these models are trained with something called RLHF, which is teaching them to work, to speak in a way that humans like. Some are more optimized for it than others. You don't want to do, like you can do something called adversarial prompting, where if you're having it check another LLM's outputs, you're purposely telling it to be critical. And then you have like another model verify whether or not that criticism was valid. You can get dangerous there. When you start adding in like 80,000 different models in there, double, triple checking each other's work, it can get very messy. And then when something goes wrong, being able to trace that back to the error is very difficult. My trick for that, I would say, is if you're using like API providers, make sure that the model you're using, if they offer it, is one that they've tuned more specifically for like production and development workloads. Like if you use GPT-4o or even ChatGPT 4o, those are very tuned for human preferences, meaning they're going to agree with the user a lot. They're the ones that you can convince 2 + 2 = 5. Humans love nothing more than to be agreed with. So as they're getting trained, just that is something that comes out of it. You can use something like OpenAI GPT 4.1, 4.1 Mini, 4.1 Nano. Those don't have as much RLHF. You do lose a little bit of performance. You lose out on some of the personality, but you're gonna get a little bit better in terms of it not being as agreeable. So,
And for the people in here that aren't, RLHF is
reinforcement learning through human feedback.
So it's a human saying, yes, you were right, no, you were
Yeah,
not.
you basically give it. Yeah, you give it a human a response. You give it like two. The way they like to do it is you give them two answers. If you've ever used ChatGPT and it's like, hey, you're getting a response from a new model, and it shows you two, and you pick the one you like. They use that directly to, one, inform if they're going to release the new model, but B, when you're doing, reinforcement learning through human feedback, you're literally training the model, given two outputs or more, to pick the one that the human liked the most, and then over time the model will learn to respond in the way that the humans liked, and that's how it's able to pick up on like really nuanced, social behavior that we can't quite describe, but it otherwise needs to learn.
So, Brian, we're sitting here relying on technologies that were invented like 10 minutes ago, like MCP and things, and we're dropping them into the ordering flow for every Domino's pizza restaurant or your billing systems and things. And that's not the expectation that a lot of these enterprise customers have, that you're using this brand new, relatively untested technology that might be brittle and might be broken and might be wrong. And they're using voice systems that they haven't touched in 10 years because they're afraid to break them. Right. How are you balancing that?
Okay, so there's some approaches you can do here. And I've discussed this with multiple customers that have approached and asked questions, 101 questions about how to deploy and implement. And I always tell them, you have a couple of choices here. You can try to keep what you have brittle as it is and try to translate that into an AI, or you can just rip it all out and replace it. And comically, Abby and I have wanted to do a thing called Pimp My IVR, where we go select a customer, a victim or whatever, and then go remake it better, and do that as like something on YouTube, just to kind of show off some of the things you could possibly do better.
Yo, dog, I heard you like menus, so I put menus in your menus so you can menu while you menu. Okay, very good.
I have just a piece of evidence. I sort of inadvertently had really strong access into the relative success of like a dialogue flow-based system and an LLM-based system because of the work that we've been doing with some of our customers around the personalization of the voice. So essentially, like after every single phone call that happened, the customers telling us which of the rhyme voices they were using, and then the outcome of that call. And in this case, it was an ordering use case. And at the time, they had two competing systems, what they were calling their legacy system, which was, again, like an intent-based dialogue flow, and then the LLM thing. And within the span of 2 weeks, so like the LLM starts, right? Like, and by the way, call success in phone ordering for food is something like state of the art now is a lot higher than it was before. But at the beginning, people hadn't really figured out the LLM stuff, and it was kind of, at its worst, was on par with the legacy intent-based classification system. And I saw that because we could just see how many orders were successful between these two systems.
And success means they actually placed the order and please send it to me. I'm happy with what.
Yeah,
okay.
yeah, correct. That's right. And then within a span of 6 months, it was it went from 60% to 70% order success, where 60% was baseline. And then via again some of this voice personalization work, some fine tuning of smaller language models, they got that up from 70 to 90% in another 6 months. Whether or not you can ever control for someone hanging up because they got to the end of the menu, the phone ordering system didn't like the price of the pizza and hung up, that you can't really control for that. But you're never gonna get 100%. But I do think state of the art for even really complex use cases is probably upwards of 90% at this point.
Brian, you looked like you had something to say. No, okay. So on that thought of the technical challenges and the technical hurdles, where are the biggest technical hurdles when it comes to integrating AI and connecting it to your voice infrastructure? Tony?
Scale and getting over the idea that it's easy for the part that actually makes it happen. What I've noticed is it's when there's a new tech cycle, it's fun. Oh, it sounds easy. I can just, you know, I think Lily said that before. I can make a toy in like an hour, right? Like, oh, I can just use like grab a voice from somewhere and make the LLM talk. I did it. I'm done. And then it's like put it on the phone. Oh, I want 1,000 of these at once. Oh, there's an emergency. Everybody called it at the same time. I'm doing well at my business, so I'm getting even more calls. Oh wait, my toy only runs on my laptop. I know I was gonna make it better later, but like I didn't realize that I had to do it already. And some of those things, I think that as we go through that exercise, the stuff that you can actually do once it's scaled is where all the real fun is. It feels like it's fun to make the thing able to do that stuff, but the thing that you do with it is more fun, and it's going to take you a year to get there. So what we wanted to do was like, how can we make that possible? Because one of my goals is that people will realize that like making a voice AI orchestrator is like writing your own database. Oh, I don't want to use MySQL. I'm just going to write one. That's to me, that's what it's like when I hear someone say, "I'm just going to make an orchestrator," you know, because it's just not like that. It's like, especially depending on how you want to be able to, the options you have to parse. Like we just added support for Amazon Novasonic. It's one of the voice files, right? We'll probably try some other ones to see the difference, right? Like we have a place now where we have the conversational latency between the two ways of doing it. One is all the words I say go right to the model, and the model sends the words back to me, and I can only do tools now, right? I gave away all the other magic powers that I have. We can almost beat it, and I think we still do. We beat it in response latency the old-fashioned way because we perfected it for a couple of years now, right? And it's thousands of lines of really complicated software. It isn't just LLM and a Perl script or something. You know, it's like, so I think as that becomes obvious, and then no one will try and do that, because there was a time when people did try and write their own web server. Like, whatever, I'll just write one. All I gotta do is listen on a TCP socket and like spit some file out when somebody asks for a certain path, and you know, like pretty soon you're like, now you have Nginx, and you're like, never mind. You know, we did that with FreeSwitch, right? Do you see anyone going around writing soft switches? So like, I think the thing with the getting over that, the next chapter has to be more clear, because like you can do so much stuff. Like if you want to dip your toe in it, the most complex IVR, but the easiest one to write in AI is voicemail, right? Because voicemail is this complicated IVR, like, please be ready to say your message, and after you say your message, press 3 to listen to it and see if you're happy or whatever. That's all replaced with like 2 sentences. First you use your markdown to record the call, unbeknownst to the AI. He doesn't even know it's recording the call, and you just tell it, the user's unavailable. The person they're trying to call is unavailable. Ask them why they're calling, right? And then you have a normal conversation. The person's not on the spot, like panicking about what they're going to say. They just say whatever they want. They can insist they want to talk to Brian and whatever. It won't let them. He has a thing that actually will let him if he wants to let that go through. But if he's not, he just wants to collect it. It posts the whole conversation to a webhook with the recording in it, and there's your voicemail, right? You can transcribe it more. You can use the transcription I already gave you. But you just like made one of the most common use cases for an IVR better, for sure. Like there's no chance. Like normal voicemail sucks. No one even, they hang up when they know it's voicemail.
And now I know why Brian won't answer my calls. Or that's probably not why, but I have written my own database and my own web server, and I highly recommend it as a hobby and not ever putting them in production. It's not fun. So, Justin, the technical challenges and the technical hurdles, what are the largest technical hurdles you've seen about connecting AI to somebody's telecom infrastructure?
Well, connecting AI to the telecom, I don't do it. I let SignalR do it. So I don't. But there's one of the things that we see commonly is when we work with call centers, well, the humans are there, you know, working in HubSpot or working in Salesforce for their customer, and they take information there, or they're going to use this other no-name CRM, but guess what? It doesn't have an API. And so you don't have this interface, and their call center platforms aren't integrated even with APIs. They have the humans driving the mouse and keyboard to do all this. So not only do you have to now start taking information in over voice with an AI, but now you also need to do the API integration. And oh, there's no API for this, so now you need, this AI agent that can do that as well. So for me, it's taking back and saying, hey, customer, let's reset expectations here on what's actually possible and like what's realistic to get done, and let's make incremental progress on this. So for me, it's connecting whatever that human is doing that's not done over an API already, because that's stuff that they could be doing right now with their existing system, and they're not, and there's a reason why. And that can come down to, this company, we're all logging in with the same username because they charge per seat license. In our call center, we only absorb 1 seat, but now you're breaking terms of service. So there's operational things that come in there as well. So for me, that's where the rubber meets the road, and it may not be connecting the AI to the technical system there. It's just an operational issue.
Yeah. Okay. Brian, let's got time for one more answer here before we're done. Where have you seen customers have the biggest technical hurdles of connecting AI to their systems?
Really, with SignalWire, it's point and click. The biggest technical hurdle they have is prompting.
Well, before using SignalWire, if they're trying to use it outside, they're connecting it to OpenAI's voice model or something like that. Where are the technical challenges there?
The knowledge and how to use the tools available to connect to other systems, they're cumbersome, they're fragile, they sometimes don't work correctly, they lag. There's all of these technical challenges that require some base level knowledge to understand exactly, especially observability. Like, why is this not working? Like, you don't have some of that. We've tied all that up in a knot, and you don't have to worry about that no more.
Okay, very good. So
one other thing.
Yes.
I'll just point it out because we dealt with this. OpenAI's APIs are different than Microsoft's hosted APIs. So it's like when you want to fail over, there are things like that you just expect to work, and they don't.
Even though it's still the OpenAI model, the API itself is different. And yeah, okay.
Wait, you're telling me Azure Foundry is difficult to use? No way.
So it's 5 o'clock. It's the end of the evening. We have all of the microphones up here, so we cannot let you ask any questions. But I'm sure at least some of the panelists will be at the game night this evening, and will not mind if you prevent them from playing games and ask them about AI implementation and deployment instead.
So, could talk for hours.
Thank you, everybody. Thank you, panelists.
Thank you.